Outcome 11.3 Histograms. A histogram is like a bar graph, except that it is used to represent continuous data so that the bars are touching. The width of each bar represents a range of numbers. So here's an example. If we look at the graph on the right, this is students' scores on a final exam. So their scores can range from 0 to 100. And each bar of our graph will show us how many students got between those numbers. So for instance, the red bar shows us how many students got between 0 and 20. But how do we find how many students got 20? If we look at the yellow bar includes students with a mark of exactly 40. So any students that got a mark of 40 will be counted in with the yellow group. Marks from 40 all the way up to 59 are included in the yellow, but marks of 60 are not. Students that got marks of 60 will be counted in the next interval and shown as green on the graph. Adele is doing a study to see how much television people in Canada watch. She's conducting a survey to find the average number of hours people watch television, and she collected the following data. I know that a histogram will be a good way of displaying this data because if I look at the time, everything is done in intervals. So between 0 and 5 hours, between 5 and 10, 10 and 15, 15 to 20, 20 to 25, 25 to 30, or more than 30 hours. Let's look at our histogram. So along the vertical axis would be the number of people, and I didn't label that, so I'm going to do that right now. And along the bottom is the number of hours watched. So the first set of data on my table is the number of people who watched between 0 and 5 hours. There was 254. So between 0 to 5, so my graph is going to go to here, I need to come up to 254. So there's 200. That would be 250, so just slightly over that square, and then I would color in that whole square. We can have the bars be different colors, or we can do them all the same. I'll maybe switch colors so it's a little bit easier for you to see. The next set of data on our table tells us the number of people who watched between 5 and 10 hours. There was 875. So up to 10, we need to go all the way up to 800. There's 875. So that would be 850 and partway through. Remember that on a histogram, our bars are going to be right next to each other because it's continuous data. And so there would be my bar for the number of people that watched between 10 and 15. The next one is between 5 and 10. The next one is 10 to 15. Between 10 and 15 hours are 684 people. So that's a little crooked, let's straighten that out. I need to come all the way up to 684, so I'm going to have to come just under that 700 mark. There we are. And then I can color in that bar. Between 15 and 20 hours of TV watched, we had 912. So my next bar is going to come up above the 900 mark. There we are. And again, coloring in that bar of my histogram. The next one is between 20 and 25 hours. This one drops way down to just 345. And so that will be the height of my next bar coming out this far. And we'll color that one in. Almost done. Number of people that watch TV between 25 and 30 hours is 123. So again, a drop. 123 would be approximately that tall. And coloring in. And the last bar on my histogram is for people that watched more than 30 hours, and that is 62. And so we want to come just higher than 1 square. Now that we have our information graphed, we can answer some questions. It says, how many people watch TV between 10 and 15 hours? Because between 10 and 15 hours is one of the intervals on our bar graph, we can find this information by looking at the table and simply reading off 684. How many people watch less than 15 hours? We're looking for less than 15 hours. 15 hours takes up the first 3 bars on our histogram. And so we need the first 3 sets of data from our data table. So there was 254 people that watched between 0 and 5 hours, plus another 875 people that watched between 5 and 10, and another 684 people that watched between 10 and 15 hours. When we add all of those up, we end up with 1,813 people that watch less than 15 hours. What information does a histogram make easier to see? It's easy to see which are the most popular times or the most popular number of hours that people watch TV. It's also easier to see the lower numbers, such as there are fewer people that watch between 30 and 35 hours or more than 30 hours. Let's do one more example. Traffic engineers watch traffic patterns to see if certain intersections need stop signs or traffic lights. An engineer installed a traffic counter to determine how many people use a particular intersection in the afternoon. His results are shown on this histogram. So on the vertical axis, we have the number of vehicles in hundreds, and along the horizontal axis, we have the different times. So it goes from 3 to 3:30, 3:30 to 4, 4 to 4:30. This little symbol at the start shows us our graph is starting at 3 and that there's some missing information. So it doesn't go from 0 to 3. That just shows a break. Answering some questions from our histogram. During what time period was there the most traffic? So if we go to our graph, the most traffic is going to be from the highest bar. And if we look at what that time period is, it's between 4:30 and 5 o'clock. How many vehicles use the intersection between 5:30 and 6? So between 5:30 and 6 is this bar on our bar graph. And we can either estimate it from our bar graph. If we had a data table, we could look back to that, but we don't. So we're going to read across to approximate how many people would have used that intersection at that time. So I would say that's about 4.5, but we need to remember that those are the number of vehicles in hundreds. So it's not 400, but it would be 450 vehicles. How many vehicles use the intersection between 3 and 7:30 p.m.? So this one, we want to look at the number of vehicles for 3 to 7:30 is the entire length of time that the study was done. To do that, we're going to need to estimate the height of each bar. So reading across to our graph, we can estimate those heights. The first bar would be about 1 high. The second one is higher than 2.5, but not quite 3, so possibly 2.8. Maybe I'll write them just above so that it's a little easier to see. The third bar comes right up to the 3. The fourth bar comes up to about 6. The next one to 5. The following one we said was 4.5. The next one's a little higher, but it's not quite up to the 5, so maybe 4.8. Then this one would be the height of 3 and the height of 2. To find the total number of vehicles, we would then need to add all of those up. So adding up those numbers, the first bar was 1 plus 2.8 plus 3 plus 6 plus 5 plus 4.5 plus 4.8 plus 3 plus 2 equals 32.1. Now remember that these are in hundreds of vehicles. So we would need to take that answer and multiply it by 100, gives us 3,210 vehicles that use the intersection between 3 and 7:30. Your turn to try some on practice number 3.